So in this particular question, we need to determine the limiting value of the given function when x approaches infinity. So upon substituting for the value of x, we have the indeterminate form of infinity minus infinity. So that means we have to convert the given function f of x into the rational form of g of x over h of x. So that can be done by rationalizing the given function. So let us begin with the rationalization. So we have limit x going to infinity. So we have x squared plus x plus 1 minus the square root of x squared plus 1. So we're going to multiply it by its conjugate, which is going to be square root of x squared plus x plus 1 plus the square root of x squared plus 1. So we have divided by the same conjugate. So that would give us the square root of x squared plus x plus 1 plus the square root of x squared plus 1. So we have limit x going to infinity. Now we have in the numerator the product, which is in the form of a minus b multiplied to a plus b. So here we can transform it to the identity a squared minus b squared. So that would give us the square root of x squared plus x plus 1 whole squared minus the square root of x squared plus 1 divided by square root of x squared plus x plus 1 plus the square root of x squared plus 1. So we have in the numerator x going to infinity. So we have in the numerator x squared plus x plus 1, and we have x squared plus 1. So we have minus of x squared minus 1 divided by the square root of x squared plus x plus 1 plus the square root of x squared plus 1. So that gives us a 1 in the x in the numerator, because the x squared and negative x squared gets cancelled out, and so does 1 and negative 1, leaving us with x in the numerator. So we have limit x going to infinity. So we have x in the numerator divided by square root of x squared plus x plus 1 plus the square root of x squared plus 1. Now we're going to divide the numerator by the numerator, and that would give us 1 divided by the square root of x squared plus x plus 1 divided by x plus the square root of x squared plus 1 divided by x, which will be equals to limit x approaching infinity. So we have 1 divided by square root of, so the x when it enters the square root, so we have x squared plus x plus 1 divided by x squared plus, similarly for the second term, we have x squared plus 1 over x squared. On further simplification, we get limit x tending to infinity 1 over square root of, so I've got x squared over x squared, so that will be 1 plus x over x squared, that will give us x divided by x squared, so that will be simply 1 over x plus 1 over x squared. Then for the second term, we have square root of 1 plus 1 over x squared. Now we substitute for the value of x, so that will leave us with square root of 1 plus 1 over infinity will be 0, plus 1 by infinity squared will also be 0. Similarly, for the second term, we have 1 plus 1 over infinity squared, which is 0, and that gives us a value of 1 over 2. So this is going to be the limiting value of the given function when x approaches infinity. So we need to determine the limiting value of the given function when x approaches infinity. So clearly this function also is giving us an indeterminate form of infinity minus infinity. So that means we need to convert the given function, if it is denoted by f of x, into a rational form of z of x over h of x. So that would mean we will need to rationalize this part of the function, which is root x plus 1 minus square root of x. So let us do that. So we have limit x going to infinity times the square root of x multiplied to square root of x plus 1 minus the square root of x. So we multiply to its conjugate, which will be x plus 1 plus the square root of x. So we also have to divide it by the same conjugate. So we have square root of x plus 1 plus the square root of x in the denominator. That gives us limit x going to infinity. So we have square root of x in the numerator. Now root x plus 1 minus square root of x multiplied to root x plus 1 plus square root of x has the form a minus b times a plus b, which can be rewritten as the square of the square root. So that will be square root of x plus 1 whole squared minus square root of x whole squared divided by square root of x plus square root of x plus 1. So this will give us limit x going to infinity. So we have square root of x. Now the square of the square root will get rid of the square root, so we'll have x plus 1 and minus x in the numerator divided by square root of x plus square root of x plus 1. So we are going to take square root of x as the common factor so that can be cancelled with the numerator. So we have 1 plus square root of x plus 1 over square root of x. So we can get rid of the square root of x from both the numerator and the denominator, and the x and negative x gets cancelled out, and that leaves us with limit x approaches infinity. So we have 1 in the numerator divided by 1 plus square root of x plus 1 over x, which will be limit x going to infinity. So we have 1 over 1 plus square root of x over x is going to give us 1 plus 1 over x. Now we substitute for the value of x, so that would give us 1 over 1 plus 1, which will be equals to half. So this is going to be the limiting value of the given function when x approaches infinity. So here in this particular question, we are given that when x approaches infinity, then the function fx has a limiting value of 1, and when x approaches 0, then the function has a limiting value of 2. And it's also given that the function is defined by the rational function ax plus b over x plus 1. So using this information, we need to find out the value of the function at x equals to negative 2. So let us begin by first using the definition of limit. So we have limit x going to 0 given fx equals to 2. So we replace fx by its value. So we have ax plus b over x plus 1, and this value is equals to 2. Now let us do a direct substitution for the value of x. So we have b over 1 is equals to 2. So this is giving us a value of b equals to 2. Then we have that when x approaches infinity, then the function ax plus b over x plus 1 has a limiting value of 1. So we do a little bit of manipulation here. So what we're going to do, we're going to divide both numerator and denominator by x, which is the highest power of both the highest power of x. So that will be a plus b over x divided by 1 plus 1 over x. Oops, this is the infinity. It's the limit, x tends to infinity. So this value is equals to 1. So we have a plus b over infinity, which is 0, divided by 1 plus 1 over infinity, which is 0. So this gives us the value of a to be equals to 1. So now that we have the value of a and b, so our value of fx will be, so we have f of x equals to ax plus b. So our a value is 1, so we have x plus b, which is 2, divided by x plus 1. So now that we have the value of f of x, so f of negative 2 will be equals to negative 2 plus 2 divided by negative 2 plus 1, which is going to give us 0 over negative 1, and that value is equals to 0. So this question is quite similar to the previous one. We have the function f given by ax squared plus b over x squared plus 1. So it is given here that when x approaches infinity, then the limiting value of ax squared plus b over x squared plus 1 is equals to 1. So we have limit x going to infinity. So we look for the highest power of x in both the numerator and the denominator. So the highest power of x is going to be 2. So we're going to divide both numerator and the denominator by x squared. So that will give us a plus b over x squared. So we're divided each term by x squared. Similarly, we're going to divide each term in the denominator by x squared. So that is going to give us 1 plus 1 over x squared. And this limiting value is equals to 1. Now substituting the value of the x, we have a plus b over infinity, which will be 0, divided by 1 plus 1 over infinity, which is 0. This is equals to 1. So that gives us the value of a, which is equals to 1. Also, it's given that the limiting value of the given function when x approaches 0, the function ax squared plus 1 divided by x squared plus 1 is equals to 1. Now we do a direct substitution and substitute for the value of x with 0. That gives us a times 0 squared, so that will be 0 plus b divided by 0 plus 1, which is equals to 1. So we have the value of b equals to 1. So now that we have the value of both a and b, so we can rewrite a given function as a, which is 1. So we have x squared plus 1 divided by x squared plus 1. Now we have both the numerator and the denominator having the same term. So we have f of x equals to 1. So now that they have the value of f of x, so f of 2 will be also equals to 1.